Today entire class will be on prime numbers. We will start the class right from basics. Then I will discuss intermediate level questions. Then I will discuss advanced level questions. Kindly reply it in the live chat. Kindly mention which place you are from or which college you are from. College and place or a location. Kindly mention before we start the class. I will be starting the class in the next 2 minutes. 90 minutes of continuous problem solving through understanding of concepts. I will be discussing a concept, then I will be taking a problem to make you understand the concept. All the varieties of questions we will discuss. All the varieties of questions we will discuss from the topic prime numbers. From the topic prime numbers, kindly reply it in the live chat. Kindly, I want each and every viewer who are watching my live class, kindly reply it in the live chat. The place you come from or the college. Or the college. We will be taking a lot of live sessions right now. Dharani, which location you are from? Nishanti is from Acharya College. Other students kindly reply. As you know, most of you, we will be just started the series of an YouTube premiere where a student can listen to a pre-recorded classroom lecture sitting in his home at his or her comfort at a designated time. I am sure you got the schedule. Other students kindly click on the share button and share it with all your friends who are preparing for aptitude examination. Prime numbers. Prime numbers. Prime numbers. Now first we will see what is a prime number. A prime numbers are the numbers which are only divisible by. Numbers which are only divisible by 1 and itself. Which are only divisible by 1 and itself. Any number which are only divisible by 1 and itself are called prime numbers. Prime numbers are the building blocks for all the numbers. Every other number is derived from prime numbers. Numbers which are only divisible by 1 and itself. This is a very important keyword. Only divisible by 1 and itself. Why? Because every number is divisible by 1 and itself. Every number is divisible by 1 and itself. But only the numbers which are only divisible by 1 and itself. Numbers which are only divisible by 1 and itself are called prime numbers. Only divisible by 1 and itself. Or in other cases, the numbers which has only two distinct factors. Numbers which has exactly two distinct factors. Why exactly two distinct factors? Because any number which are only divisible by 1 and itself. Only divisible by 1 and itself, because it is divisible by only by 1 and itself. 1 is one factor and the number itself is another factor. So numbers which has exactly two distinct factors. Numbers which has exactly two distinct factors are called the prime numbers. So both the definitions are more or less the same. They use the same concept. A number which is divisible by exactly two distinct factors are the numbers which are only divisible by 1 and itself. Don't miss the keyword only. If I remove the keyword only, every number is divisible by 1 and itself. 6 is divisible by 1 and 6. 8 is divisible by 1 and 8. For example, 7 7 is divisible by only 1 and itself, which is 1 into 7. Therefore, 7 is a prime number. Therefore, 7 is a prime number. If I take 12, if I take 12, 12 is divisible by 1 and itself, which can be written as 1 into 12. But in addition to 1 and 12, it is also divisible by 2 and 6. It is also divisible by 3 and 4. But the keyword says that it is only divisible by 1 and itself. 12 is not only divisible by 1 and itself, it is divisible by 2 and 6, and it is divisible by 3 and 4. Therefore, 12 is a composite number. 12 is a composite number and 7 is a prime number. I hope the definition is very clear to you. A number which is only divisible by 1 and itself are called prime numbers. Composite numbers are the numbers which has got greater than two distinct factors. In other words, another very important point, just keep listening and keep writing the way it is being discussed, sir. And numbers which has exactly two distinct factors. Suppose if I take 1, 1 is nothing but it can be written as product of two natural numbers as 1 into 1. I said distinct. So one has got 1, another one is similar. So one has got only one distinct factor. A prime number definition is it should have exactly two distinct factors. So the conclusion is 1 is neither prime. 1 is neither prime. What do you mean by composite number? A composite number is a number which has got greater than two distinct factors. A composite number is a number which has got greater than two distinct factors. Suppose we took an example 12. Does it have more than two distinct factors? Yes. 1, 12, 2, 6, 3, 4. A composite number is a number which has got greater than two distinct factors. But one does not have greater than two distinct factors. Extremely important key point. Very important key point. 1 is neither prime nor composite. 1 is neither prime nor composite. 1 is neither a prime number because it does not have two distinct factors, nor a composite number because it does not have greater than two distinct factors. 1 is neither prime nor composite. This is the key point number 1. Numbers which are only divisible by 1 and itself. That means because it is divisible by 1 and itself only, it will have neither prime nor composite. 1 is neither prime nor composite. I hope this is clear. Just all you have to do is just listen, sir. Rest everything I will take care. By the end of the class, you will see a complete understanding of prime numbers. Instead of reading 32, 3, 5, 7, 11, 13 and so on. If you observe all these numbers, 3 is an odd number, 5 is an odd number, 7 is an odd number, 11 is an odd number, 13 is an odd number. So next important key point is 2 is the only even prime. 2 is the only even prime number. The prime number which is even is the only number is 2 is the only even prime. Please underline this. We will discuss some good questions based upon this. 2 is the only even prime number. A prime number series is of the form 2, 3, 5, 7, 11, 13, so on and everything. Now if you observe, every prime number greater than 3, if you observe, it is of the form 6k plus or minus 1. Every prime number greater than 3, it is of the form 6k plus or minus 1. For example, 5 can be written as 6 into 1 minus 1. 7 can be written as 6 into 1 plus 1. 11 can be written as 6 into 2 minus 1. 13 can be written as 6 into 2 plus 1. But if I take every prime number greater than 3 is of the form 6k plus or minus 1. If this is true, this is true. But reverse may or may not be true. But reverse may or may not be true. Reverse, may or may not be true. That means every prime number greater than 3 is of the form 6k plus or minus 1 is a necessary but not sufficient condition. It is a necessary but not sufficient condition, to tell whether the number is a prime number or not. Suppose for example, if I take 25, 25 is of the form 6 into 4 plus 1. 6 into 4 plus 1. But is 25 a prime number? No. 25 is a composite number. Listen carefully to this line. Every prime number greater than 3 is of the form 6k plus or minus 1. But the reverse case, what is the reverse case? All the numbers which are of the form 6k plus or minus 1, it may be true, it might not be true. Suppose if I take 73, it is nothing but 6 into 12 plus 1. 6 into 12 plus 1. 6 into 12 plus 1. Is 73 a prime number? Yes, it is a prime number. We will see how to check whether a number is a prime or a composite number little later. Right? If you observe, one is of the form 6k plus 1, which is a composite number. Another is of the form 6k plus 1, which is a prime number. Listen again carefully. Every prime number greater than 3, it is of the form 6k plus or minus 1. Reverse may or may not be true. Reverse may or may not be true. I will develop a lot of questions to explain you this line, and I will also develop a lot of questions to explain you this line. You might ask me a question, sir, if you observe other than 2 remaining all the numbers are odd numbers, can I also say that every prime number greater than 2, it is of the form 2k plus or minus 1. Why it is 2k plus or minus 1? Because other than 2, all the numbers are odd numbers. Every odd number can be expressed in the form of 2k plus 1 or 2k minus 1. You can use 2k plus or minus 1 or 6k plus or minus 1. But taking 6k plus or minus 1, some tough questions can be solved very easily. Some tough questions can be solved very easily. Right from the basic, then intermediate, then advanced prime numbers. 2 is the, in this slide, 2 important key points are 2 is the only even prime number, and every prime number greater than 3, it is of the form 6k plus or minus 1. Next key point. Next key point. This we will use it in product of 2 coprimes concept. 1 to 50, there are 15 prime numbers. 1 to 50, there are 15 prime numbers. 51 to 100, there are 10 prime numbers. I will show you tomorrow where this concept is used. 1 to 50, there are 15 prime numbers, and 51 to 100, there are 10 prime numbers. There are 10 prime numbers. I am repeating again before we get into a question. Important key points. Prime numbers. Prime numbers have got exactly 2 distinct factors. This is the first key point. Prime numbers have exactly 2 distinct factors. Second key point, 2 is the only even prime. 2 is the only even prime. Every prime number can be written of the form 6k plus or minus 1. Reverse may or may not be true. Last key point, every composite number is derived from prime numbers. Every composite number is derived from a prime number. Every composite number is derived from a prime number. For example, 12. 12 is derived from 2 prime factors, which are 2 and 3. Composite number is a children and prime number is the father. Composite number is derived from prime number. Composite number is derived from prime number. With this understanding, one by one, we will try to solve. We will try to cover close to 24 problems today, covering all the basic varieties from prime numbers. 24 numbers, problems we will solve. Right? I hope the definition is clear. Basic definition of prime numbers is clear. Now see the first question. All the problems are based on definition based problems. Write down in the same order so that it will be crystal clear to you. It will be crystal clear to you. Definition based problems. Definition based problems. Definition based problems. Now see. First question. Is 3 power 11 plus 5 prime or composite? 3 power 11 plus 5 prime or composite. He is asking whether this number 3 power 11 plus 5, whether it is a prime number or a composite number. Whether it is a prime number or a composite number. Now see the solution. This order you will not get it in any textbook. At the end of the class you will understand the thematic based learning of the class. 3 is an odd number. 3 is an odd number. 11 is also an odd number. I am just writing the nature of the number. Plus 5 is again an odd number. 5 is again an odd number. Odd power any number is nothing but an odd number. Odd power any number is nothing but an odd number. Odd plus odd numbers. If I add two odd numbers, I will get an even number. I will get an even number. But what is the concept that we discussed just a few minutes before? We discussed saying that the only prime number which is even, the number is nothing but 2. This is the concept we discussed. Other than 2, there is no number which is even and can be a prime number. But he is asking a number 3 power 11 plus 5. He is asking a number 3 power 11 plus 5. So other than 2, there is no number which is an even number and a prime number. So answer for this question is 3 power 11 plus 5. The number is a composite number. Elementary level question, basic understanding of the question. Answer for this question is, it is not a prime number, but it is a composite number. It is a composite number. What is the concept used in this problem? The concept used in this problem is 2 is the only even prime number. 2 is the only even prime number. Again I am repeating. Every question I will repeat minimum twice so that it will be crystal clear to you. 3 is an odd number. Odd power any number is odd. 5 is an odd number. Odd power any number is odd. Odd plus odd. Odd plus odd is nothing but an even number. Odd plus odd is nothing but an even number. Odd plus odd is nothing but an even number. We are saying that 3 power 11 plus 5 is an even number, and we are saying that the only prime number which is even is 2. Other than 2, there are no even prime numbers. So answer for this question is 3 power 11 plus 5 is a composite number. 3 power 11 plus 5 is a composite number. I hope the first question is clear to you. I hope the first question is clear to you. Now let us go to the second question. Now let us go to the second question. Another question. Second question. Is 973 prime or composite? Second question. Is 973 prime or composite? Now before solving this question, please write down two important key points. A power n minus b power n is always divisible by a power n minus b power n is always divisible by a minus b if n is a natural number. A power n minus b power n is always divisible by a power n minus b power n is always divisible by a minus b if n is a natural number. For example, if I take a square minus b square, a square minus b square is a minus b into a plus b. Yes, it is divisible by a minus b. If I take a cube minus b cube, a cube minus b cube is a minus b into a square plus ab plus b square. Yes, if n is 2, which is an even number, it is divisible by a minus b. If n is 3, which is an odd number, power could be an even number or power could be an odd number. In both the cases, it is divisible by. In both the cases, it is divisible by a minus b. Extremely important concept. A power n minus b power n is always divisible by a minus b. A power n minus b power n is always divisible by a minus b if n is a natural number. A power n minus b power n is always divisible by a minus b if n is a natural number. Now we will use this concept in this question. Question is 973. Can 973 be written in the form a power n minus b power n? 973 is nothing but 10 cube minus 27. 1000 minus 27 is 973. This is nothing but 10 power 3. 27 is nothing but 3 power 3. Yes, right now we got the form a power n minus b power n. So, a power n minus b power n is always divisible by a minus b. Always divisible by a minus b. 10 minus 3 is 7. 10 minus 3 is divisible by 7. Now, if you observe what is the definition of a prime number, the definition of a prime number is it should be divisible by, only divisible by, the definition of a prime number is it is only divisible by 1 and itself. Only divisible by 1 and itself. It should only be divisible by 1 and itself. It should be only divisible by 1 and itself. But here it is divisible by 7. So what is the answer for this question? Answer for this question is number is a composite number. Number is a composite number. Number will be a composite number. I hope the concept is clear. First is a basic elementary question. Next is a new concept and the application of the concept. Again, I am repeating it. The concept that is used in this question is a power numbers. Capital N is nothing but a set of natural numbers. I hope it is clear. Next, we will do more and more questions so that it will be clear to you. Not a single doubt, you will get it in the class. Just all you have to do is just listen to the class with utmost attentions. Right? With 14 years of experience, I developed a PPT which starts from basic to advanced. Just follow the PPT. A power n minus b power n is always divisible by a minus b if n is a natural number. I used this concept. A number, if it is a prime number, it should be divisible by only 1 and itself. But in this question, it is divisible by 7. Any number which is not only divisible by 1 and itself is called a composite number. So answer for this question is a composite number. Answer for this question is a composite number. Another problem based upon definition. Another problem based upon definition. I hope the second question is clear. Third question. Another concept. Third one. Now if you see. Third question. Check whether 143 is a prime number or not. Check whether 143 is a prime number or not. Now, if you see the concept, see another variety. What we did previously is 973, we tried to write it as 10 cube minus 27. But unfortunately, 143, these 27 happen to be 3 cube. 143 cannot be written as 10 square plus 43, but 43 cannot be written as a square of a number because perfect square never ends with 2, 3, 7 or 8. So this logic may fail. This logic may fail of writing the number as of the form a power n plus or minus b power n. I hope it is clear. Every question is carefully designed, sir. Every question has been kept in the PPT. Thinking from a student perspective, students might think, what if it does not happen? All the doubts have actually become the questions. Check whether 143 is a prime number or not. Another concept. Now listen carefully. Suppose if I take 12, what are the factors of 12? Factors of 12 are 1 will divide 12, 2 will divide 12, 3 will divide 12, 4 will divide 12, 6 will divide 12, 12 will divide 12. These are the numbers which will divide 12. I hope you are all there with me. Now, I'll suppose if I take square root of 12. Square root of 12 lies from square root of 9 and square root of 16. So, because it lies from square root of 9 and square root of 16, what we can do is, you put a line after 3 and 4, because root 9 is 3 and root 16 is 4. Root 16 is 4. Now, if you observe carefully, all the factors greater than root 10, all the factors greater than root 10 are actually derived from, are actually derived from, are actually derived from factors less than root 10, are actually derived from factors less than root 10. Can I say 4 is derived from 2? If a number is not divisible by 2, where is the question of being divided by 4? If the number is not divisible by 2 and 3, how can it be divisible by 6? If a number is not divisible by 3, how can it be divisible by 12? That means all the factors greater than root 10 are actually derived from factors less than root 10. All the factors greater than root 10 are actually derived from factors less than root 10. I hope this concept is clear. Now, why am I taking? So, how to check whether a number is prime or composite? There is an alternative way. How to check whether a number is number? We will call that number as n. We will call that number as n. Listen carefully to every question, sir. How to check whether a number n is prime or composite? N is prime or composite. So what you do is, first take root of n. Write all the prime factors less than root n. Take all the prime factors less than root n. Why only prime factors? Because composite number is derived from prime number, which we discussed. If none of the prime number, if none of the prime numbers, none of the prime factors divides n, then the number is a prime number. Then the number is a prime number. We will take an example of 143 and we will try to solve. For a smaller number, still more and more models are there. We will cover one by one. For a smaller numbers, how to check whether a number is a prime or composite? First, take root n. Step number 2, take all prime factors less than root n. Why we are not taking prime factors greater than root n? All the factors greater than root n are actually derived from factors less than root n. So, you don't need to take 4, 6 and 12, right? If you are taking 1, 2 and 3, because 4, 6 and 12 are nothing but derived out of 1, 2 and 3. This is, right, basic way to check whether a number is a prime number or not. This is not a final way. This is the basic way to check whether a number is a prime number or composite. Take a prime factors less than root n. Now what we will do is, with the understanding of this concept, let us solve one question. Let us solve one question. Question is, how to check whether 143 is prime or not? First we have taken, first we will take n, then we will do root n, then we will do all the prime factors less than root n, then none of them divides, none of them divides, n is a prime number. This is a flow chart. N is a prime number. This is the flow chart. 143, square root of 143 it is closer to 12. 12 square is 144. Next is all prime factors less than root n. All the prime factors less than root 12. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. None of them divides the number. 2 will not divide 143. 3 will not divide 143. 5 will not divide, 7 will not divide. 143 is nothing but 11 into 13. Because it is divisible by 11, answer for this question is this is a composite number. Answer for this question is this number is a composite number. I hope it is clear. I hope it is clear. Kindly reply it in the live chat in case if it is clear to you. How to check whether a number is a prime number or not? Basic way, take n, take root n, take all the prime numbers or prime factors, prime numbers less than root n, none of them divides, then the number is a prime number. 143 square of root of 143. 12 square is 144. 12 square is 144. I took all the prime numbers less than 12. 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. I hope it is clear, right, sir? We will do one more question so that it will be clear to you. Kindly reply it in the live chat if it is clear to you. I'll do one more question. Suppose instead of 143, if the question is 667, check whether 667 is prime or composite. Check whether 667 are prime or composite. First take n, then take root n, then take all the prime numbers, then take all the prime numbers less than root n. If none of them divides, then the next number is n is a prime number. This is the flow chart. This is the flow chart we have to follow. Then we will see the demerit of this concept. 667, root of 667, closer to 26. 26 square is 676. All the prime numbers less than root n. Prime numbers less than root n. 2, 3, 5, 7, 11. 13, 17, 19, 23. None of them divides. Let me come from the back side. If I come from the back side, 23, 667, it is nothing but 23 into 29. This is divisible by 23. If none of them happens, then only the number is a prime number, but it is divisible by 23. So therefore answer is 667 is a composite number. 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 This is the basic way to check whether the number is a prime or composite. Why we have taken all the prime numbers less than root n, greater than root n, the numbers which we got greater than root n are the derived numbers from the factors less than root n. If none of them divides the number, then the number is a prime number, or if at least one number divides, if at least one number divides, then the number is a composite number. Then the number is a composite number. I hope it is clear, right? Kindly reply it in the live chat. Till here, is it clear? Then I will increase the level of difficulty. I want maximum students to reply it in the live chat if it is clear to you. Is it clear to you? I hope it is clear to you. I hope it is clear. Shall I go to the next question? Kindly reply. I hope it is clear. Shall I go to the next question? Next question. Next one. Now this is the basic way of doing it. Now if I take into advanced level, another variety. Another variety. Fourth question. 2 power 12 plus 3 power 9 prime or composite. Question is 2 power 12 plus 3 power 9 prime or composite. Another concept. Another concept. Write down the concept. A power n plus b power n is always divisible by a power n plus b power n is always divisible by a plus b if n is an odd number. If n is an odd number. Another concept. Every problem that you are solving, I will tell you the concept and I will tell you how to apply that concept. A power n plus b power n is always divisible by a plus b if n is an odd number. A power n plus b power n is always divisible by a plus b if n is an odd number. For example, a cube plus b cube, because the power should be an odd number. A cube plus b cube is nothing but a plus b into a square minus ab plus b square. What is that statement? A power n plus b power n is always divisible by a plus b if n is an odd number. If n is an odd number. So a cube plus b cube, n is a 3 odd number. It is divisible by a plus b because the n value is an odd number. A cube plus b cube is always divisible by a plus b if n is an odd number. Now let us see 2 power 12 plus 3 power 9. 2 power 12 plus 3 power 9. Power should be an odd number. Can I write like this? 2 power 4 power 3 plus 3 cube power 3. 3 cube power 3. 2 power 4 power 3 plus 3 cube power 3. Now if you observe, a power n plus b power n is divisible by a plus b if n is an odd number. It is divisible by a plus b. So 2 power 4 is 16, 3 cube is 27. 17 plus 16, 27. 16 plus 27 is 43. Number is divisible by 43. Number is divisible by 43. If a number is only divisible by 1 and itself, then the number is said to be a prime number. Now it is divisible by 16 plus 27, 43. So answer for this question is the number is a composite number. Number is a composite number. Another concept. First we checked whether the number is odd or even. Concept 2 we checked by using a power n minus b power n, which is always divisible by a minus b. Concept number 3 we used root n concept. We took all the prime numbers less than root n. If none of them are dividing, then the number is a prime number. At least one is dividing, then the number is a composite number. Next, we have discussed another concept. A power n plus b power n is always divisible by a plus b if n is an odd number. I hope it is clear. 4 concepts we discussed to check whether a number is a prime number or not. Prime number or not. The concept used is a power n plus b power n is always divisible by a plus b if n is an odd number. Fifth question. Fifth one. Another examination based question. Question is 2 power 2007 plus 1 prime or composite? 2 power 2007 plus 1. So these is nothing but 2 power 2007 plus 1 power 2007. 1 power 2007. So what is that? We discussed the concept. A power n plus b power n is always divisible by a plus b if n is an odd number. If n is an odd number. So these is nothing but it is divisible by 2 plus 1, which is 3. Why? Because 2007 is an odd number. Why? Because 2007 is an odd number. 2007 is an odd number. So what will be the answer for this question? Answer for this question will be, the number will be a composite number. Number will be a composite number. For all the students who are planning to write management exams like CAT examination, this is a CAT replica question. This is a CAT replica question. Very simple question, but many of the students thought that it's a difficult question. It is not a difficult question. It is an easy question if you know the concept. Toughest paper becomes the easiest paper if you know the concept. Easiest paper will become the toughest question if you don't know any of the concepts. If you do not know any of the concepts, you should get a good mentor, learn as many concepts as possible so that you will crack your exams in the first attempt. Otherwise, you will keep on writing the examination. 22 will become 23, 23 will become 24. By the time you reach 27, you will see your friends scaling up great heights in life and you are writing the same exam for more than 2 to 3 times. The choice lies with you. 2 power 2007 plus 1. Fifth question. I hope it is clear. Sixth question. Sixth question. This is the concept I used it. Sixth question. Sixth question. Step by step concept. Easy, medium, advanced. Easy, medium, advanced. Next. Sixth question. Another question is 27 followed by 5 zeros ending with 1. Is 27 followed by 5 zeros ending with 1. 27 followed by 5 zeros ending with 1. Question is this number prime or composite? Is this number prime or concept? The reason why I am discussing this is, there is also a drawback. Drawback if the number of digits are more, by using that concept of prime factors less than root n. If you use that prime numbers less than root n in this case, it will be an extremely cumbersome process or a tedious process. Cumbersome process it will take to check whether this number is a prime or not using this concept. That is the reason, if one concept fails, other concept should be there. This you can write it as 27 followed by 6 zeros plus 1. So these are nothing but 27 into 6 zeros ending with 6 zeros can be written as 27 into 10 power 6 plus 1 power 6. So these are nothing but 3 into 10 square whole cube, and these are nothing but 1 square whole cube. So these are nothing but 300 whole cube, and it is nothing but 1 whole cube. So a power n plus b power n. A power n plus b power n is divisible by a plus b if n is an odd number. If n is an odd number. If I apply this concept here, it is divisible by 300 plus 1, which is 301. 301 is nothing but 7 into 43. Any number divisible by other than 1 and itself, the number will not be a prime number. So answer for this question is, the number will be a composite number. You don't need to refer any book on prime numbers. After you listen to my 2 sessions of prime numbers, everything will be crystal clear to you. Which method to use when, which method should not be used, what is the best method, how to check if the number of digits are more, the concept, what is the demerit of the concept, why are we discussing another variety. In fact, you can also teach someone entire prime numbers if you listen to the class and practice all the problems. I hope it is clear. This question is to explain what if the number of digits in the number increases. What if there are more digits in the number? What if there are more digits in the number? All the doubts that you are getting in your mind will be created as questions by me. More digits in the number. I hope it is clear, right, sir? Sixth question. Seventh question. Idea is clear, right? This question is to explain the drawback of this concept. This time taking will be huge if the number of digits in the number. if there are more digits in the number. Seventh question. Are you all with me? Kindly reply it in the live chat so that I can get into the next level. Are you all there with me? I hope you are understanding it step by step, right from the definition of a prime number to an application of definition. Reply it in the live chat so that you will understand. I will understand that everybody is on common thing. Effective from today, you will see a lot of classes coming from an ANC YouTube channel. We will be telecasting the pre-recorded classroom sessions for the students who cannot enroll. And also, we will be adding a lot of content to the enrolled students. I am sure the students who are enrolled, you can see the kind of content is being added into your online portal. There are a lot of mocks that are added. There are a lot of placement papers that are added. And very recently, one of my old student who has done an MBA from one of the finest business schools in USA, she also extended her help to help the student. She is also keeping a lot of videos on verbal. In addition to huge number of videos, you will see videos on modal verbs, you will see videos on conjunction, you will see close to 10 to 12 hours of new verbal content added. Enrolled students, the content is not static. You will keep on getting more and more content as and when we feel that whatever we gave to students, we are not, we ourselves, we want to give more. I hope it is clear. Next. This class also will be available only to that enrolled students in the next 4 days so that they can revisit it. Non-enrolled students come at that particular time and listen to the class. Enrolled students, you can watch the same class any number of times. Next one. I hope the 6th question is clear. 7th one. Another beautiful question. What is you will not find this kind of conceptual approach and the problems. You will see all the definition based problems in the local textbooks. What is the last digit of the 9-digit number? There is a 9-digit number and the digit is 1970019D. Okay. All the digit numerical values are given except the unit digit. Except the unit digit. What is he asking? What is the last digit? That means he is asking what is the value of D. Okay, the question is clear. What is the value of D such that the number is a prime number? He is specifying a condition that what should be the value of D such that this number is a prime number. Such that this number is a prime number. Such that this number is a prime number. This entire problem is based upon the divisibility rules. If you are comfortable with the divisibility rules, this question will take hardly less than 10 seconds. The first thing is, listen carefully, option 3. Option 3 is saying what is the value of D. If I take option 3, what is option 3? 5. Let me replace the value of D with 5. 197000195. Right? Students who know the divisibility rule of 5. Divisibility rule of 5 is unit digit should be 0 or 5. Unit digit here it is 5. That means this number is divisible by 5. This number is divisible by 5. If the unit digit is 0 or 5, if the unit digit is 0 or 5, if the unit digit is 0 or 5, that means the number is divisible by 5. If it is divisible by 5, if it is divisible by 5, how can it be a prime number? How can it be a prime number? So option 3, 5 is out. 5 is out. And next one, suppose if I take, let me add the digits. Let me add the digits. Why are we adding the digits? Let me use the divisibility rule of adding the digits. If the sum of the digits, if the sum is divisible by 3, if the sum is divisible by 3, then the number is not a prime number. Let me add the digits. Adding the digits, 1 plus 9 plus 7 plus 0 plus 1 plus 9 plus t, 9 plus d, 1 plus 9, 10, 10 plus 7, 17. 17 plus 1, 18. 18 plus 9, 27, which is 27 plus D. 27 plus D. Suppose if I take option, suppose if I take an option 2, which is 3, what it will become? 27 plus 3 is 30. 30 is divisible by 3. 30 is divisible by 3. So, second option is out. Similarly, if I take fifth option if I take, it is 9. So, if I do 27 plus 9, which is 36, 36 is divisible by 3. So, 9 is also not possible. So, these 5 is eliminated because of the divisibility rule of 5. 3 is eliminated and 9 is eliminated because of the divisibility rule of 3. 5 is eliminated, 3 and 9 is eliminated. Now, we are struck with 1 and 7. Now we are struck with 1 and 7. Now we are stuck with 1 and 7. Now let me take 7. If I take 7, these are nothing but 197,000,197. So these are nothing but, just now we did a similar question. Can I write this question like this? 6 zeros plus 197. So these are nothing but 197 into 10 power 6 plus 197. Now immediately you can write it as 197 into 10 power 6 plus 1. 10 power 6 plus 1 is nothing but 10 square whole cube plus 1 whole cube. 10 square whole cube plus 1 whole cube. A cube plus B cube, it is divisible by A plus B, which is 10 square plus 1, which is nothing but 101. If a number is divisible by 101, how can the number be a prime number? 7 also is eliminated. Beautiful question which talks about the divisibility rule of 5, which talks about the divisibility rule of 3, which also talks about the concept of using a power n plus b power n, which also uses the concept of using a power n plus b power n. A power n plus b power n. So this is eliminated, these eliminated, these eliminated, these eliminated. The only option left is 1. You can check it out in your free time in Wolfram Alpha. 197,000,191. 197,000,191. That is, the number is nothing but a prime number. Number is nothing but a prime number. I hope it is clear. Very, very good question, where the divisibility rule of 3, divisibility rule of 5. Here we discussed 3 concepts. One is using the divisibility rule of 5. Another is using the divisibility rule of 3. Another is nothing but using a power n plus b power n is divisible by a plus b if n is odd. A power n plus b power n if n is odd. I hope it is clear, right? Idea is clear. Again I am explaining you once again. If I put the d value 5, the unit digit will become 5. If the unit digit is 5, the number will be divisible by 5. If a number is divisible by 5 other than 5, it cannot be a prime number. So option 3 is out. If I add all the digits, 1 plus 9, 10, 10 plus 7, 17, 18, 27, 27 plus d. If the d value is 3, 27 plus 3 is 30. 30, sum of the digits 30, that means it is divisible by 3. 27 plus d, if d value is 9, 36 is also divisible by 3. So 3 is out and 9 is out. If I keep the unit digit as 7, the number is divisible by 101. Number is divisible by 101. If a number is divisible by 101, how can it be a prime number? 7th question, especially the students who are not comfortable in maths, who are at a beginner level in the aptitude vertical, kindly listen to the second time. 7th question. 8th question. 8th one. Please write down the 8th one. Another quality question. Largest prime factor. Largest prime factor for 9995 004. That means 0004. There is a number 9995004. This is the number. Now in this number, there is a factor, it seems, which is the largest prime factor. What is that prime factor that will divide this number? That is the question. 9995004, there is a number. This number is divisible by some prime factor. What is the large? Whenever I said it is a largest prime factor, suddenly 99 is there in the option. 99 is a composite number. 99 is a composite number. 99 is eliminated. 93 is eliminated because 93 is 3 into 31. So 93 is eliminated, 99 is eliminated. We are struck with two options, 97 and 101. We are struck with two options, 97 and 101. Now listen carefully. Now listen carefully. Another new concept. Divisibility rule for 101. Divisibility rule for 101. We will discuss this concept and then we will apply the concept. Divisibility rule for 101. Now see the concept. Extremely important concepts. Extremely important concept. Suppose if I take 10 square divided by 101. 100 divided by 101. Negative remainder is minus 1. 101s are 101. Negative remainder is minus 1. Suppose if I take 1, 2, 3, 4 divided by 101. Reminder, when 1, 2, 3, 4 is divided by 101, can I write like this? Reminder 1, 12 into 10 square plus 34 divided by 101. 12 into 10 square plus 34 divided by 101. Now see. 10 square divided by 101, what is the value? Minus 1. So it is nothing but minus 12 plus 34 divided by 101. 34 minus 12 is 22. 22 divided by 101 is 22. 22. This is the concept. This is the first example. First example. 10 square divided by 101. 100 divided by 101 is minus 1. Minus 12 plus 34. 34 minus 12 is 22. 22 divided by 101 is 22. Second example. 1212 divided by 101. 1212 divided by 101. This can be written as 12 into 10 square plus 12 divided by 101. 12 into 10 square plus 12 divided by 101. 10 square divided by 101 is minus 1. Minus 12 plus 12, it is 0. Minus 12 plus 12, it is 0. Minus 12 plus 12, it is 0. 10 square divided by 101 is nothing but minus 1. Two important key points. Two important key points. Please write down. Two important key points. First key point. Any two-digit number written even number of times. Any two-digit number written even number of times. If I write a two-digit number even number of times, it is always divisible by 101. Extremely important point. First write down, sir. Write any two-digit number written even number of times. Any two-digit number written even number of times. If I write a two-digit number even number of times, that is always divisible by 101. Suppose if I write 34 divided by 101. What is the concept? Any two-digit number written even number of times. 34 is a two-digit number. It is written 4 times. So it is always divisible by 101. It is always divisible by 101. Any two-digit number written even number of times. Any two-digit number written even number of times. It is always divisible by 101. Any two-digit number written even number of times. It is always divisible by 101. I hope the concept is clear. I hope the concept is clear. 10 square divided by 101 is nothing but minus 1. 10 square divided by 101 is nothing but minus 1. So the same concept is used here. This is key point 1. Now let me write down key point 2. Key point 2. Please write down, sir. Key point 2. Divisibility rule for 101. Divisibility rule for 101. Start from right hand side. Start from unit digit. Start from unit digit. Take a group of 2 digits. Take a group of 2 digits. Take a group of 2 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. Why it is alternatively add and subtract? This point we will underline it and we will understand it. Alternatively add and subtract. Why? Because 10 square divided by 101 is minus 1. 10 power 4 divided by 101 is 10 square whole square minus 1 square, it is plus 1. This is the divisibility rule for 101. Start from the unit digit, take a group of 2 digits, alternatively add and subtract. First we will do an example. Example 1, 2, 3, 4, 5, 6 divided by 101. What is the remainder? Remainder 1. 1, 2, 3, 4, 5, 6 when divided by 101. What is the remainder? What is the concept here? First take the number 1, 2, 3, 4, 5, 6. Take a group of 2 digits. I took a group of 2 digits. Alternatively add and subtract. First plus, then minus, then it is plus. Then it is plus. Why plus minus plus came? So it is nothing but 12 into 10 power 4 plus 34 into 10 square plus 56. 10 power 4 divided by 101 it will give you plus 1. 10 square divided by 101 it will give you minus. As usual it is plus. I am sure it is clear right now why it is plus minus plus. So 56 plus 12 is 68. 68 minus 34 is 34. What is the answer for this question? 34. You don't need to divide it by 101. In case if you are so interested, then I am sorry to say my classes are not for you. My classes strengthen your concepts. My classes will make you think. My classes increases your logical ability. My classes enhances your analytical ability. So start from unit digit, take a group of 2 digits, alternatively add and subtract. Alternatively add and subtract. Extremely important concept through this problem, 8th problem, largest prime factor for. Because we got 101 here, I am discussing the divisibility rule for 101. What is the concept? Start from the unit digit, take a group of 2 digits, alternatively add and subtract. Alternatively add and subtract. Now we will use this concept, otherwise it will become extremely difficult. There are few students who have taken 2 to 3 minutes to solve. If you know the concept, you can solve this question in less than 10 seconds. We will see the concept. I hope it is clear. Now see. Question. It is 9995 0004. 0004. Suppose if I assume 101 is the answer. What is the concept? First take a group of 2 digits. Yes, I took a group of 2 digits. Plus minus, alternatively plus minus. 95 plus 4 is 99. Minus 99 minus 0 is minus 99. 99 minus 99 is 0. That means the number is divisible by 101. What is the question? Largest prime factor. There is one more option, 97. If the answer itself is 101, 97 is less than 101. So what is the answer for this question? Answer for this question is largest prime factor for this number is nothing but 101. Largest prime factor for this number is 101. I will not check 97 because 97 is less than 101. 101 is greater than 97. Question is largest. Question is largest. I hope it is clear. Extremely important question where a new idea on how to find the divisibility rule for 101 is discussed. How to find the divisibility rule for 101. This is the new concept. New concept. Let me repeat the flow. First we discussed the definition of a prime number. Then we discussed how to check whether a number is a prime or composite. In that one we used a variety of concepts. The first concept is the number should not be an even number. Next concept is a power n minus b power n is always divisible by a minus b. Third concept is taking all prime numbers less than root n. Fourth concept is a power n plus b power n is always divisible by a plus b if n is an odd number. Fifth concept is if options contain prime number, how to find the divisibility rule for that particular prime number. Till now, is it clear beta? I want a maximum number of students to reply it in the live chat. I hope is it clear? Is it clear? Unfortunately, this kind of structure or this kind of concepts ranging from basic to advanced, it is very rare to get it in any of the institutes. And second thing is, right after the class is over, you cannot watch this class again as the class will be shifted to a private mode. Now, if you see another variety, exactly one of the 5 numbers listed below is a prime number. Out of 5 numbers, one out of the 5 numbers, it is a prime number. Which one is the prime number? There are 5 options. In that 5 options, one number is a prime number. One number is a prime number. Remaining 4 are composite. We know how to check whether a number is a prime or composite. We have solved enough number of questions, so we will use some of the concepts whatever we have discussed. So these are nothing but 10 power 6 minus 9. So this can be written as 10 cube whole square minus 3 whole square. A power n minus b power n. A power n minus b power n is always divisible by a minus b. So the first option, it is divisible by 10 cube minus 3, 997. 997. First is out. First is nothing but 10 power 6 minus 9. 10 power 6 is 10 cube whole square minus 3 square. A power n minus b power n. It is always divisible by a minus b. Already we discussed this concept. If you apply that concept, it is showing that the first number is divisible by 997. Similarly, 73 means it is 27 less. Second one is 10 power 6 minus 27. So these is nothing but 10 square whole cube minus 3 whole cube. Minus 3 whole cube. So these is nothing but 10 square minus 3. 100 minus 3. It is divisible by 97. If it is divisible by 97, how can it be a prime number? It is out. Fourth one, 3, 5, 6 zeros plus 1. Already we discussed. 10 power 6 plus 1. So it is nothing but 10 square whole cube plus 1 whole cube. A power n plus b power n. It is divisible by a plus b. 100 plus 1 is 101. Answer is divisible by 101. Fourth one out. We are stuck between 3 and 5. We are stuck between 3 and 5. These are nothing but 8 into 10 power 6 minus 27. 8 into 10 power 6 minus 27. So these are nothing but 2 into 10 square whole cube minus 3 whole cube. 2 into 10 square whole cube minus 3 whole cube. A power n minus b power n is always divisible by a minus b. So it is nothing but 2 into 10 square minus 3. So 200 minus 3. 200 minus 3 is 197. Number is divisible by 197. Fifth one not possible. So answer for this question is third option. Third option, it is nothing but 498. I hope the idea is clear. Quality questions, conceptual questions, right? The more and more you watch all our classroom videos, you will get addicted to this kind of conceptual learning. Most of the students are fed up with the traditional. In case if you try to show our notes or the videos to anybody in your friend circle, they will be awestruck. They will say that from where this kind of questions you got. Lot of investment of time, effort and money has gone into creating an probably India's best video course. If you are not a part of it, I don't know how to tell you. All I can say is go behind the concepts. Don't waste too much of money. Go behind the formula based approaches. Ninth question. Tenth one. Tenth one. Any classes whatever I take, don't miss any of the classes. So answer for this question is third one. Answer for this question is third one. Now see. Now till now we have discussed definition based problems. Now we will discuss basic level problems. Now we will discuss basic level problems. Now see. Basic level questions. P1 into P2 into P3 and so on up to P7 is 510, 510, 510, 510, P1 less than P2 less than P3 less than P7 and P1, 2, 3 till 7 are prime numbers. This is a cat replica based question. This is a cat replica based question. Let me write down the question. P1 into P2 into P3. Okay, there are 7 prime numbers. All the 7 prime numbers are multiplied. Yes, they are multiplied and the product is 510, 510. And the product is 510, 510. 510, 510 is an even number. First observation. Next, he is saying that P1 is less than P2, P2 is less than P3 and so on, it is less than P7. So he is asking what is the smallest prime number that can be taken. P1 is smallest. What is the value of P1? What is the value of P1? Assume. If I assume all P1, P2 till P7 are odd. If I assume all are odd. What is odd into odd like that 7 times and so on up to odd. Odd into odd, any number of times it is odd. But the question is 510, 510 is an even number. All the 7 cannot be odd. And there is only one even number that is possible. And the lowest prime number which is even is nothing but 2. So answer for this question is P1 is 2. P1 is 2. P1 is 2. So what we have done, we have proved it by assumption. If I assume all the 7 prime numbers are odd, if I assume that all the 7 prime numbers are odd into odd and so on up to 7 odd numbers. 7 odd numbers product is odd. But 510, 510 is an even number. 510, 510 it is an even number. All the 7 cannot be odd. One has to be even. What is the smallest prime number? What is the smallest prime number and even? What is the smallest prime number and even? Smallest prime number and even number is 2. So answer is smallest prime number P1 value will be 2. Smallest prime number P1 value will be 2. I hope it is clear. Next one. Another question. We did n prime numbers multiplication. Now let us do prime numbers addition. Let us read the question. P1, P2, P3 till P7. So P1 plus P2 plus P3 and so on up to P7. It is 1, 2, 3, 4, 5, 6. Okay. Same thing. P1 less than P2 less than P3 and so on up to P7. P1 less than P2 less than P3 and so on up to less than P7. And P1 to P7 are prime numbers. So P1, P2, P3 and so on up to P7 are prime numbers. Okay. What is the smallest? Same idea. Assume that all the prime numbers are odd. Assume P1, P2 and so on up to P7 are odd. Assume all the 7 numbers are odd. Let us see what will happen to the nature. All the 7 numbers are odd. So it is odd plus odd. Next it is odd plus odd. Next it will be odd plus odd plus odd. There are 7 odd numbers which I am adding. Let me see what will be the nature after adding. Odd plus odd is an even number. Odd plus odd is an even number. Odd plus odd is an even number plus odd. Even plus even is an even number. Even plus odd is an odd number. Even plus odd, it will be an odd number. Right hand side should be an odd number. But according to the question, right hand side 1, 2, 3, 4, 5, 6 is an even number. 1, 2, 3, 4, 5, 6 is an even number. That means all the 7 cannot be an odd number. One has to be an even number. What is the smallest prime number? What is the smallest prime number? What is the smallest prime number which is even? Answer for this. Again the question will be P1 will be equivalent to 2. I hope it is clear. P1 plus P2 plus P3 and so on up to P7 is 1, 2, 3, 4, 5, 6. The root cause of the problem is the right hand side in the question. The right hand side in the question is nothing but an even number and the number of prime numbers which are given are nothing but odd. If I add odd number of odd numbers, resultant will be odd. But according to the question, resultant right hand side is an even number. So answer for this question is P1 equivalent to 2. P1 equivalent to 2. The root cause is right hand side is an even number and odd number of prime numbers are added in the left hand side. 11th one. Again this question is of the level cat level. It does not matter whether it is a cat level or a bank level or an SSC level. All it matters is whether you know all the concepts. Take my word, when you complete the session 2 of prime numbers in your notes, in case if you are writing it with neatly in a pen and a notebook, at the end of prime numbers you will realize that it is crystal clear to you with not a single doubt. 11th question. I hope it is clear. Next one. Next question. Next one. Another beautiful question, sir. 12th question. Now if you see. Question is P equivalent to 51 factorial plus 1. P equivalent to 51 factorial plus 1. How many elements are there in the set? P plus 1, P plus 2, P plus 50 are prime numbers. P is 51 factorial plus 1. How many elements are there in the set? P plus 1, P plus 2 till P plus 50, which are prime numbers. First we need to understand what is the definition of factorial. N factorial is nothing but n into n my product of all the natural numbers starting from 3 to 1. Product of all natural numbers starting from n to 1. Suppose if it is 4 factorial is 4 into 3 into 2 into 1. Similarly, If it is 51 factorial, which is given in the question, which is nothing but 51, 50, 49, and so on up to 3 into 2 into 1. I hope, especially the students who are from non-mathematical background, I hope the definition of factorial is clear to you. Now he is asking, there are some numbers p plus 1, p plus 2 till p plus 50. How much elements in the set are actually prime numbers? How many elements in this set are actually prime numbers? Now if you see p plus 1, if I take p plus 1, p is nothing but 51 factorial plus 1, which is nothing but 51 factorial plus 2. 51 factorial plus 2. Now if you observe carefully, 51 factorial 51 factorial is nothing but 51, 50, 49 and so on up to 3 into 2 into 1. This number contains 2. This is divisible by 2. That means it is an even number. 2 is again an even number. If I add two even numbers, I will get an even number. There is no even number other than 2 which is a prime number. So p plus 1 is definitely not a prime number. 51 factorial plus 1 plus 1, 51 factorial plus 2. Suppose if I take p plus 2, p plus 2 is nothing but 51 factorial plus 1 plus 2, 51 factorial plus 3. 51 factorial contains 3. That means 51 factorial is divisible by 3. 3 is also divisible by 3. That means answer is divisible by 3. If the number is divisible by 3, p plus 2 will be a composite number. P plus 2 will be a composite number. Suppose if I take p plus 3, which is nothing but 51 factorial plus 1 plus 3, which is 4. 51 factorial is an even number. 4 is again an even number. Even plus even, it will become an even number. There is no even number other than 2, which will become a prime number. Now if I continue this discussion, till p plus 50, p is nothing but 51 factorial plus 1 plus 50. So which is nothing but 51 factorial plus 51. 51 factorial is divisible by 3. 51 is also divisible by 3. So answer is divisible by 3. Answer is divisible by 3. It will become a composite number. P plus 1 is not a prime number. P plus 2 is not a prime number. P plus 50 also is not a prime number. So what is the answer for this question? Answer is 0. There are no elements in the set which are prime numbers. Put a star mark on this question. Extremely good question to understand the divisibility rules. Extremely good question. Quality questions, we will discuss it in the class. High quality questions, write the questions which can come in future questions. Most of you are watching the videos. You know the fact that I am an author of 9 mathematical books. Obviously, there will be a difference between a person who wrote 9 mathematical books listening to a class and the person who sees the solution and just solves it, becoming a replacement to the solution. It's useless activity. It is a useless activity sitting in a class which will not make you think for 90 minutes. Sit in my class for 5 to 10 minutes, you will understand that something right. By the end of the class, you ask yourself, what did you learn? You will find a plenty of good concepts in your notebook. It's of no use going to the traditional methods, right? So again, I am repeating, this is the definition of n factorial. Next, p plus 1, 51 factorial plus 1, 51 factorial plus 2, 51 factorial contains 2. It is divisible by 2. It is divisible by 2. Idea is clear, right? 12th one. I am sure the idea is clear. Because you are seeing the new variety of questions, I will do one more similar question. You don't need to worry, especially the students who go through my online course, close to 35,000 questions I will make you solve as a part of the video course, especially if you are from MBA prep package, which is our number one bestseller. Another question. The number of prime numbers, such that prime numbers is, so the numbers are like this. One is 1999 factorial plus 1. The next number will be 1999 factorial plus 2, 1999 factorial plus 3. Next is 1999 factorial plus 4, and so on up to 1999 factorial plus 1999. There is one. Now if you see, same thing, 1999 factorial, just similar to the previous question. Many students thought that it's a difficult question, but actually it's an easy question. 1999, 1998, and so on up to 3 into 2 into 1. Same approach. This is divisible by 2 plus 2. So answer is an even number. It is not possible. 1999 factorial. It contains 3. This is divisible by 3. 3 is also divisible by 3. Answer is divisible by 3. Similar to the previous question. 1999 factorial. It is an even number. 4 is an even number. Even plus even is an even number. Answer even number should be divisible by 2. 1999 factorial. This contains 1999. And these also divisible by 1999. So answer is divisible by 1999. All the numbers are either divisible by 2 or 3 or 5 and so on. Answer for this question is 0. Very, very good quality question. If you do not know the concept behind the question, you will term this question as a very difficult question. But according to me, this is not a very difficult question. It is a very easy question. In case if your teacher or any of the institute or the books that you are referring has covered this kind of questions. From the last 14 years of my experience, close to 70 to 80% of the questions which will come in your main exam are either covered in video format, or covered in the test format, or covered in the ebook format, which are the three components which I use to make a student learn a concept better. Videos, tests and ebooks. I hope it is clear, right sir? Idea is clear?
Press the bell icon on the YouTube app and never miss another update.